Hi, Anna. Hi, Pietro. Can you guys hear me? And can you see my screen? I can't hear anybody. I want to make sure everything's okay on my end here. Anna, are you talking? I can't hear.
Now you can hear me?
I sure can. Thank you. Can you see my
Okay.
screen?
Yeah, we can see.
Thank you.
You're welcome.
Okay, it's 10 o'clock. We'll get started. So what I want to do was I'll go through the Module 10 assignments first, and then we'll go through the kinds of questions you'll see on the test that relate to Module 10. All right, so the main focus will be on problems like what you're seeing here, where you need to do matching type situations like we've done in the past with modules 7 and 9. And the same rules apply here as applied to those. Now, there is a little bit of a wrinkle here. You'll notice that for this particular one where we're being asked for the molarity of something. All right, let me give you a little bit of background here that might help you with the assignment, also with the credit and practice quizzes as well. And that is the notion that concentration which has the unit big M or moles per liter. Both of those are the same thing. And it equals moles of solute over liters of solvent. Actually, I'll change that a little bit. I'll change it to volume of solvent in liters. So that's where we end up with this moles per liter from, is from the moles of solute over the volume of solvent. Now, just a reminder is what I mean by solute and solvent. Let's say this is like an Alka-Seltzer. That would be the solute. And the liquid in here, that would be the solvent. That's what's doing the dissolving. And this is what concentrations are always about. There are a multitude of concentration units. Molarity or concentration is just one of them. So the other interchangeable term you'll see here is the term molarity. as well. So concentration, molarity, they both mean the same thing. Does anybody have any questions so far?
None of this.
Now, if you're looking for molarity, then you can see how we might go about that. But the thing here is, with this one here, I've given you one of the bits and pieces you need to actually solve the problem, and that's putting the 1 liter in the 4 position. So I've done that a lot here as you look through these examples. And the reason for that is because I didn't want you to get confused about where different bits and pieces go, because, you know, the 1 liter could have gone in 2 possibly in order to still make this work. But I'm putting it over here, and that's going to define where the 1, 2, and the 3 go. So if we're looking here and we're looking for molarity, which is concentration, we know we're going to do moles, and we're going to do divided by the liters of solvent, which is going to be water here. So the way this is set up is we've got our, I'm going to move this over a bit here. There we go. The way we've got this set up is going to be 0.0650 moles. Now it's times 1 over 34.0 mils. So that's going to be my starting point there. Now, often people will ask, well, what's this 1 about? I mean, what kind of unit is it going to have? Well, it doesn't really have a unit, because we're just using it as a tool here to do a division. Why are we doing a division? Because we need concentration. Concentration is moles of solute over volume of solvent. Now, the other wrinkle here is that volume needs to be in liters. So we need to do one more step here to convert that volume into liters. And we put milliliters up here. We'll put liters down the bottom here so that the milliliters cancel. And we'll be left with 1,000 milliliters over 1 liter, which is how we end up with this 1 liter in this position over here in the problem. So technically, yes, this 1,000 mils over 1 liter could have been here, and this 1 over 34.0 could have been here. Yes, that's true. But I preclude that possibility by actually giving you the position of the 1 liter in the equation that's given. Does anybody have any questions so far? Okay. I wanted to do maybe a couple of problems just of different sorts here, so you can see how we can make use of this equation that we're starting with up here. And the next one here is looking for a volume. And what we can see from this specific equation here is that if we rearrange it, we can do this. We can say volume of solvent in liters equals moles of solute divided by concentration. And how do I get that? Just by rearranging that formula that I've got up there. Just swapping the volume and the concentration, which I'm allowed to do because I'm multiplying both sides by volume and dividing both sides by concentration. Of course, that unit there would be molar or moles per liter. That's not going to change for the concentration. So how do we handle that here with this kind of problem? Well, knowing that we need moles of solute, and if we're starting with grams here, which we are, we know that our first step is to try and get to moles. So that's going to be our first aim here, is to get to moles. Because I have this equation here, that's what I'm going to use. So I'll do moles and grams, and the relationship there is 1 mole and the molecular weight, which is given 162.20. So that's the first step. We now have this moles of solute, but we're going to have to divide by the concentration. Now, the division by the concentration, there's another way of doing that. We can say that the volume of solvent here, actually I'm going to move this down a little bit. Is another way of expressing it, equals moles of solute times 1 over concentration. Molar. So that's the other way of looking at it. What's another way of expressing 1 over concentration? Well, it's flipping it over. And we do have a concentration here, and you can see it here, 2.30 moles per liter, or M. And I could express that by doing it this way, 1 liter over 2.30 moles.
Professor Richard?
Yes. Mm-hmm.
And in this part of the equation, can you put a 2.30 just M, or you need to put mole?
No, you could do that as well.
Okay.
So 1 over 2.30 M. I was just about to say that.
Okay.
You beat me to it.
Okay. So you can put M or you can put mole.
You can either put mole and mole on the bottom and liter on top, right? You have to do both.
Okay, got it.
Or
just one?
Or just one and the M on the bottom.
Okay, yeah, good. Thank you.
Yeah, but you can't get away with just putting moles on the bottom.
Okay, thank you.
And what we're looking for here is a volume in mils. So we do need to do a conversion at the end here. So we've got liters on the bottom, milliliters on top, and we'll have 1,000 mils and 1 liter. And that will finish off our problem there. So it's not, I mean, it looks really complicated initially when you first start. But once you realize that it's really just a manipulation of that initial formula where you've got concentration, which is moles of solute over volume of solvent, then the whole thing becomes a lot less complicated. Now, there's also some conversions between milliliters and liters you have to do along the way, but knowing where those go is not too bad, because you know what needs to cancel and you know what you need to be left with at the end. But if we do that, then we would just be left with milliliters and we'd be fine. Does anybody have any questions so far?
No, this.
Okay.
I have a question about some specific problem. I think.
Can we hold off on that, Anna, and we'll get to it in a second?
Yeah, sure, no problem.
Okay. I wanted to cover a couple of more problems here in the assignment. Then I'll get your specific problem.
I think the problem I want to stay in this.
Oh, okay. Well,
yeah.
Good. Okay. Well, which one is it? Maybe we'll.
Let me see. I think it's a 15, but let me tell you, it's a 50.0 gram sample of the KH2PO4.
Okay, it's a titration problem. But I'll do that one when I get there. Okay.
Yeah. Okay. No problem.
Okay. I know what you're talking about, and I think I will get to do that in a minute. All right. So we've looked at problems there where we want molarity. Now we've found a problem with volume. Let's look for one where we need. There we go. Grams. So this would be number 10 here. So we're looking for mass. If we're looking for mass, what we're really looking for is moles. And moles, if we rearrange this, moles of solute, which would also end up leading to grams as well. So we know how to do that. Moles of solute is equal to concentration times, in molar, times volume of solvent in liters. enough room there to put it next to it, but it's a multiplication that we're dealing with here. And what that means is we could either take the volume and put that first and multiply it by the concentration, or we can put the concentration first and multiply it by the volume. So I'm talking about this step here, which is really by its own nature interchangeable, these two here. So if we start off with 2.50 moles per litre, because we're given that, the problem, we know we have to multiply that by the volume, and the volume here is 153.0 mils. The issue though is that this volume needs to be in litres, so we do a conversion here. Mils goes on the bottom to cancel, litres goes on top, and it'd be 1 litre and 1,000 mils. At this point, if we were to stop the problem right here, you can see that the litres would cancel, the millilitres would cancel, and we'd be left with just moles. But we can't stop there, we need to get grams. And we do have a way of doing that. We can have grams, and then we put moles on the bottom here, and it's going to be the molecular weight, which is given to us, 159.62 over 1 mole. All right, so that's how we could get from a concentration and a volume to a gram amount. Does anybody have any questions? So that's pretty much all the combinations that you need to be concerned about for the different ways that we can arrange this particular calculation that we have up here. It's really important for us to be aware of that. Okay. So Anna, I'm going to move on now to these kinds of problems that you were asking about, and let's see if I can find the one that you were talking about here. Now what these problems do is they combine the concept, I can't really find it here, Anna.
Let me see. Yeah, because I think it's, what is second over there? How many? You are past really far, I cannot see.
I'm sorry.
Sorry.
But did you say KH2PO4? I have
Yeah,
a feeling that one's actually in the credit quiz.
yeah.
I don't think it's in the assignment.
Oh, okay.
Yeah. So let me go through some of these in the assignment. I think that'll help you, and then we will go through.
Yeah, because this one you have there, the number 15, this is about the, okay, similar to when they say the volume, what's the volume of the, yeah. And this is the different equation because you started just with one, you know.
Right. Mm-hmm.
Yeah, but you can do this one if you want, and after that we can pass for the.
Yeah. I'm going to do a couple of these.
Yeah, sure.
But I want to start with some different things and finish with some different things. So we'll look at the first one here, which is what we're looking for is the molarity of the HBr solution. Now this is a problem where we're combining what we knew about module 9, which had to do with stoichiometry, and this equation that we're talking about in module 10. Okay. So the challenge for this kind of problem is knowing what you're going to start with and what you want to end with. Now, generally speaking, one rule of thumb I can give you is that when you're looking at a problem like this, look at what you have the most information about. In this case, we've got 2 bits of information about sodium hydroxide. We've got a volume and we've got a molarity. So those are present here and here, this and this. So those are the 2 things that allow us to have information about this sodium hydroxide. There's only one piece of information about HBr. So we know that that's going to be what we're going to be after as well. So we always start off with what we have the most information about. And then we can also look at the problem as well to figure out what we want. And you see, we want the molarity or the concentration of the HBr solution. So that's what we're going to work towards, is moles per litre. And I think that's an important point as well, is knowing what you want at the end. And that's what we want, is moles per litre. So we're going to start off here with the modified flowchart that I was using in module 9. And it's something like this. QA gives mole A, mole B gives QB. Now in this case, the QA is going to start with either grams of A, litres, or molarity. So those are the kinds of things we can start with. These are the kinds of things we can end up with. We can end up with grams of B, litres of B, and molarity of B. But the point of this flowchart is to give you a little bit of direction and say, well, what do you need first? Well, you always need moles. That's the bottom line. You always need moles first. And 9 times out of 10, if you've got a concentration and a volume, you'll just be multiplying those together. Or in fact, in 10 times out of 10, if you've got a concentration and a volume, you'll just be multiplying them together to get moles. And that's reflected over here. Now, what can you put first? You could put the volume first and then the concentration. Yeah, that'd work. But this is set up actually giving you the concentration first. So that's where you should start. So it's going to be 1.50 moles per litre of A. Well, actually, we'll do a little bit of finagling here. We'll do moles of A per litre times the volume, which is 34.21 millilitres. Now, of course, as you can see there, we're not going to be able to cancel the litres with the millilitres like that to be left with our moles of A, which is what we want in our first step. So what we're going to do is do a conversion here, which would be 1 litre over 1,000 mils. Now, if I was to stop the problem right here, this is where I would be at. I'd be at this moles of A business. I'd be right here. That's where I would be. And my next step is to get to moles of B. Now, to do that, I use the reaction equation. And if I'm saying that A here, actually I should probably do this. I'll say A is equal to NaOH and B is equal to HBr. Give a bit more context here. I know that presently I have moles of A, which means that if I have moles of A on the bottom, it's going to cancel. But what I want is moles of B. Now the relationship between those you get that from here, from the reaction, 1 to 1. So it's going to be 1 and 1 there. Remember, if I stopped here, all I would have is moles of A. So the next thing I need to do is, well, I'm at moles of B, what I want here is molarity. And to get to molarity, per what I've got over here, is moles of solute divided by volume of solvent. So it's going to be times 1 over the volume I have, which is 25.00 milliliters. Now that would be moles per milliliter. So I need to do a conversion here, and we'll do milliliters here, 1,000 mils over 1 liter.
The part of the question, you have a 25.00, this is milliliters, will be the B, right?
Yeah, that's right. Okay. Because we want moles of B per volume of B to get the concentration. And the 1 there, again, we're multiplying by 1 over because we're dividing.
Okay.
So moles of solute divided by volume of solvent. And that's what the 1 is about. Again, no unit on the 1 because we're dividing by it. But we're just, again, using this equation. Okay, does anybody have any questions?
Now this.
Okay. Let's look at something where we need something else at the end. Okay, so this one, we're looking for grams of CaCl2. So if we go with what we were talking about before, you can see we've got a lot of information about A. So A is going to be this AgNO3 solution. And B, what we want is going to be the calcium chloride CaCl2. You'll notice that we again have this same pattern going here where we have the concentration and the volume. So we multiply those together to get moles. So 0.750 moles of A per litre times the volume that we're given, which is 250 dot mils. By the way, this dot here is important. There's a lot of frustration here because sometimes people will put 250 without the dot there as an answer. Then they get all upset with me when they get it marked wrong. Well, the problem is that 250 and 250 dot are two different numbers. And if you're given it as 250 dot, that's how you've got to report it when you and record it when you do the problem as well. So just be aware of that. So at this point, we would need to do a conversion. So to be liters here and then milliliters, 1 liter, 1,000 mils. And at this point, we would have, that would be moles of A. Now we're interested in getting to moles of B. So moles of B will be on top, moles of A will be on the bottom. And we can see that the relationship there is going to be 1 mole of B to 2 moles of A. Yeah. And you can see we know what A is. A is AgNO3. You've got a 2 there and you've got the 1 here. So now we're at moles of B. The last thing we want is grams. So grams of B can go on top, moles of B can go on the bottom. And we have a relationship that defines that. That's the molecular weight. 110.98 grams over 1 mole. And that'll give us our mass that we need of B. All right, any questions? Okay, just want to do one more here, and that is let's see if we can have a volume problem here. There we go, number 17. Let's do that one. I think, if I recall, Anna, I think this might be related to that same problem, but we'll see. If it's not related, it's going to be close.
Okay.
All right, so what are we starting with? Well, we're starting with an amount of FeNO33. That's going to be our A. And the NaCl, that's going to be our B. Well, it actually says that in the problem as well. But the thing is, we want B, which is NaCl, because the question is being asked about that, what volume of NaCl. So we're going to start off with the A, which is 225 grams. And the first weigh station is going to be moles. So moles of A over grams of A. We actually have something that relates to that. We've got the 1 mole of A is equal to the molecular weight 241.88 grams. Now we know that we need moles of B next. So moles of A goes on the bottom, moles of B goes on top. The relationship here is going to be, let's see, A is the FeNO33, so it's 1 mole of A, 3 moles of B. So we go 1:3 at that point. And what we need here is a volume. We need a volume of B. Now, to get this, it's very similar to what we talked about earlier. And I'll just repeat that. So if we want a volume of solvent, it's going to be moles of solute divided by concentration. And that's going to be in molar or moles per litre. But the important point I'm trying to get at here is that at this point in the problem where we're at, we've got moles of B. What we need is a volume. So we're going to have to divide by the concentration. We are given a concentration here. You can see it's 2.50 mole per litre. So that would be 1 litre over 2.50 moles. So one way of B. So one way of dividing something is to flip it over, multiply it and flip it over. So instead of 2.50 moles per litre, what we've got is 1 litre over 2.50 moles. And what we're effectively doing there is dividing by the concentration, because we're multiplying by what we call its inverse or its flip. See, by doing that, look at what happens. Everything cancels except for litres, which is what we want from the problem, except that we need to, yeah, it does say in litres, so that's where we would end up. We would just end up with litres. If we wanted to get millilitres, we could do one more step and multiply by 1,000 mils over 1 litre, but we don't have to do that because we're just looking for litres out of this problem.
So if I want to finish in milliliters, just I need to multiply for 1,000
Well,
and one
you'd have,
liter for cancel.
you
Or
do
no?
that. You would do that.
Okay. Yeah, I think this resolved my question.
Yeah.
Because the another problem, the difference finish, what is the volume by milliliters?
Mm-hmm.
So, okay.
Yeah, that's what you would do. I mean, at this point, I mean, in this problem, we're only after litres, but one more step, just one more step, and
Okay.
you'll get your millilitres.
Yeah, cool. Okay. Thank you.
All right. Yeah, that's one of the trickier ones, Anna, is figuring out a volume, because you need to do that step where you flip the concentration over to multiply it, which is effectively dividing by the concentration.
Okay.
All right. Does anybody have any other questions about any of these things that we've gone through here in the Module 10 assignment? Okay, let's take a look. Let's take a look at the practice quiz here. And I think what you'll see is a lot of the same kinds of problems. The only difference being the way that you are expressing the answers. So for something like this, instead of doing a matching exercise, what you'll do is you'll type in what's required here. Now, again, the guidance I can give you with something like this is if you're really worried about what the formatting looks like, just go down, don't even put anything in, just go down, submit the quiz, and take a look at the answers. So let's do that just for kicks. See, I'm not even putting any answers in. There we go. There's your answers, along with the formatting. Just remember, the brackets or the parentheses here are not part of the answer. It's what's in the parentheses that is accepted as the answer. You'll notice sometimes more than one thing's accepted. So for here, you've got molar or you've got moles per litre, they're the same thing. So either answer would have been acceptable for that. So that would be my advice there, especially if you're worried about the formatting. Oh, where do I put spaces? What units, how do I express the units? What do units look like? Well, that's how you do it. That's how you'll know. So looking through these problems, you can see they're the same kinds of problems as we've been dealing with. Let me focus on this one here for a couple of seconds, and that's this one with the percent. I get some questions about this one, generally because of significant figure issues. So if you're looking at something like this, a percentage is always part divided by whole. So we're looking for the mass percent of this solution. The whole thing here would be the sodium fluoride plus the water. So the setup looks something like this. It looks, let's see, 60.0 grams of NaF over 60.0 grams of NaF plus 100 dot grams of water. Now, because this is a mixed operation, we need to figure out what this is before we do the division. And that would actually be 160 dot grams in total. So that would mean that we'd have 3 sig figs over 3 sig figs, and that would determine our answer. So that's something I can definitely tell you need to do, is look at that bottom part. Make sure you get the sig figs from there first by doing the addition rules, which go by the number of places past the decimal point, which is one place past the decimal, no places past the decimal. So the answer comes out to no place past the decimal here. I know it's annoying, but you know, this is just what sig figs are about. They're put on earth to annoy us. All right, does anybody have any questions?
No updates.
Okay, let's take a look. You see same thing here with we've already been through these. It's just a different way of setting them out. And I think this is the one.
Yeah, I think I will say the same. Yeah, I think this is what I asked you.
Yeah. So do you think you're okay with that now?
Yeah, I think I'm okay. It's the same you did, but it just then the what I asked you, they need milliliter. So I just need to put one step more.
Yeah, that's right. Yep.
Yeah. Understand. Thank you.
Yeah. So for this one, you can see how it's panning out. We're looking for the moles first, then we do the mole ratio, which is going to be 2 to 1, which is here 2 moles of A to 1 mole of B. And then we're multiplying by 1 over 50.00 mils. And this is the reflection of this concentration calculation here, where we want concentration at the end. Here we have molarity. That's what we want at the end. And the way we get that is we have moles divided by volume. So that's why it's times 1 over 50.00 mils. And then, as you said, Anna, we do that last step where we convert those milliliters into liters.
Yeah. Cool.
All right. So that's pretty much it. All right, let's take a look at the kinds of problems you can expect to see on the test that relate to Module 10. And you can see it's all very similar to what we've just been doing. So by doing the homework, you're actually practicing for the test as well. Okay. So you can see here, you can practice with the on-lock calculator just by clicking on it. And what you can do is you can bring it out as another tab here, and then you can shrink that, and then you can have it next to your test. And then that's how you could practice with the on-lock calculator. I think that'll work out nicely for you all. Okay, let's have a look. So the kinds of problems.
Can I tell you what you need to put there?
Yeah, what's up?
No, can I do this one?
Yeah.
You want to do?
Oh, no, okay. No, sure. No, go for it. Yeah.
Okay, just I make sure I understand. Okay, so in this case, I need to know how many grams, right, of the NaL I have. So I need to.
It's an I. It's a capital I.
I.
L.
Okay. So in this case, in the number one, I need to put the milliliters, right? So 150.0 milliliters
Hang on,
times,
let's start this. We'll start this from the beginning.
okay,
So what's going to go in number one here? What are you going to put?
the milliliters, right?
That's right. Yeah, 150.0 mils. That's right.
Okay, times 1 liter over 1,000 milliliters.
That's
Okay.
good. Yep.
Time, because I need grams, I need to put 149.89 grams, right?
Yep.
And for 1 mole, because okay.
Yep. And that'll give you your answer.
And here, let me see. Here will be 2.00 times 150 times 1 divide times 149.80. This is 880. Okay, 89 divide 1. So this will be how many? I need 3 figures. So I have 44 point, I know, because I have 96. So I can say 45.0 or no?
That's right.
Okay.
Yep. 45.0 grams.
Yes.
Now, it does say here, don't include compounds in the working. So just because we're only dealing with one thing, we don't need to worry about the compound. We
Okay.
will have to worry about it later when we're doing the A's and B's, but not for this. So
Okay.
yeah, what you've said is completely correct there, right down to the significant figures at the end where we would require 3 because that's the smallest number of sig figures that we're dealing with in the problems.
Okay.
That's good. Now, understand that the kinds of problems that you can get here for, looks like the first 3 problems here, we can do grams, we can do molarity, and it looks like we can do volume. So it looks like you get one of each of those. I think that's the case. So you need to be able to do those. Do you want to do the next one, Anna?
Yeah, sure.
Okay.
Okay.
Hang on, let me,
So,
I'll just do it over here. All right. So we've got 20.0 grams. All right. What are you going to do first?
so we are going to, this is molarity, right?
Yes.
So I need 1 mole over 41.99 grams.
Right. Now, the reason you're going for moles first is because at the end, what we need is concentration or molarity, which
Exactly.
is moles of solute over volume of solvent. So we need to get those moles first. So that's good. It's a good place
Okay.
to start. All right, what do we do next?
So next, I need to put 1 in the milliliters I have, and I have 40.0 milliliters.
So you're saying 1 over that, right?
Mm-hmm.
Yeah. Now, the reason you're doing that is because we need to divide by the volume.
Exactly. So after that, I need to multiply for 1,000 milliliters and 1 liters.
That's right. That's good. And that'll give us our answer. How many sig figs will our answer have?
I need 3.
Yes, you do. That's right.
Okay. So this will be 20.0 times 1 divide 41.99 times 1 divide 40.0 times divide 1. So this will be 12.0 because it's 11.96. So I need to fix, oh no.
Yeah, I'm not sure if that's the right answer. I'm not convinced it is.
I am sorry. Yes, I have mistake. I put.
So what I was going to say, Anna, as I heard you putting all that stuff into the calculator, you can just go ahead and ignore the ones and then just multiply everything that's on the top and just divide by everything that's on the bottom. So in your
Oh, okay.
calculator, you can really simplify things by just doing 20.0 divided by 41.99 divided by 40.0 and multiply all of that by 1,000.
Oh, okay, okay. Yeah, good idea.
Okay, so what do you end up with if you...
It's too much numbers. Let me see.
Yes, I know.
Oh my God. Okay, and then, okay. Oh my God, the answer is, I don't know. It's completely different what I have. It's a 190. No, this is impossible. Oh, professor.
Okay, that's all right.
I lost. All right, let me see. Mm, You got it or no? 0 times 1 divided. It's 41.99, right?
Yeah, that's right.
Okay. And 140. Okay, I got it. Yeah, it's 11.90.
11.9. That's right.
Mm-hmm.
11.9. And we'll do what, three
So
six digits?
at this case, it's wrong. I put 12.0.
Yeah,
Okay,
yeah,
okay.
yeah.
So
But
the answer will be 11.9.
that's right. Yeah, because
Okay,
the next digits are 0,
okay,
so we just round to the 9.
okay.
If you were rounding to 2 stick figures, it'd be 12,
Mm-hmm.
but that'd be it. 12, 12 and nothing else after it, but not 12.0.
Oh, okay.
Yeah, so I think you were double rounding there.
Yeah, okay.
But still, I mean, the main point I wanted to get across here was just how to put stuff into your calculator, just to make it a little bit easier,
Yeah,
make it a little bit less complicated.
yeah. This was my mistake in the test number 3 because it's 0.999 and I put 1
Mm,
and you need 3 significant figures. So the answer would be 0.99.
right.
Yeah, it's funny because if you put 1 or you put 0.99, the result would be the same, because the
Mm,
calculator relay is, is a rounding,
mm.
but significant figures.
That's right. That's right.
Yeah.
All right. Let's take a look at this one here. You want to be brave and try this one?
Okay, this will be what volume of water. Oh, in milliliter. Okay,
Mm-hmm.
okay. I think this is you will delete. Okay, 10 point. Okay,
Okay, give me a second.
it's okay.
Let me erase this. We'll start again. All right, so we're starting off with 10.0 grams.
Exactly. So at this case, I need to put first grams, right? So 1 mole over 58.10 grams times
Okay, that's
the,
right so far, but let's see why we're doing that.
okay,
Because we want volume of solvent, which is going to be moles of solute over the concentration. So our first step is to find the moles, and that's why you're doing what you're doing there. Okay, continue on.
okay. So here I would say I would put 1 liter. No, oh no, I don't know. 1 liter over 0.400 mole. Oh no.
That's right. Yeah.
Okay.
Because what you're doing here is you're taking that mole and dividing by the concentration.
Okay, yes.
There's your concentration here, and multiplying by the flip of it, which would be 1 liter over 0.400 moles, or quite
Or I can
acceptable.
say 1 over 0.44 m, no?
Yes.
Yeah, yeah,
Yeah.
cool.
Either one of those is quite acceptable. Although
Okay.
on the test though, one might not be accepted, but if it wasn't, then you could always email me and say, hang on, Dr. Musgrave, it looks all right to me.
Okay, you fix it. Okay.
And I'll
So
fix it.
we are going up the milliliters. So at this
Yep.
case, I need to multiply 1,000 milliliters over 1 liter.
Yep, that's right.
Okay. Let
And
me
that'll give us our
working with
final
the
answer.
calculator.
Mm-hmm.
10.0 times 1.
Now remember, it's just 10.0 times 1,000 divided by 58.10 divided by
Yes.
0.40.
Mm-hmm. Okay, so close divided 1 divided 1 equal. This will be a 430. How many figures I need? 3. So 430 point.
Yep,
Yes, milliliters.
that's right. That'll get you there. And that dot, yeah, we need to put that dot at the end.
Yeah,
Otherwise,
because you need to specify the zero count. Yeah,
that's exactly right. That's exactly, yeah, that's
because
good.
you cannot put 430.1 because you have significant figure over there, right?
You're right. And we know we have 10.0, which is 3. And
Uh-huh.
we can't have any more significant figures than what we have the least of,
Okay.
which
Okay.
is 3. This 3, that's 4. So the answer is going to come out to be 3.
3. Exactly.
Yeah.
Okay. Well, I think I'm good.
All right.
I think I learned.
All
It's too
right.
much, it's like
Yeah.
you need to have clear what is the answer you need,
Yeah. That's exactly
because this
right.
is what are you going.
That's right. Yeah. From your
Right.
mouth to God's ears. That's right. That's what I
Yeah.
want to hear. That's great. Yeah. You want to look at the answer, figure out what you want, then you can apply the formula correctly.
Exactly. Because you if you made a mistake in the position for example mole, milliliters or liters, so
Mm.
it will be wrong.
Yeah. That's right.
Yeah.
All right. Well, let's take a look at this last one here, number 4. Did you want to have a go at this, or do you want me just to go through this one?
No, it's okay. I can try. Let me
Okay.
see. A 65 milliliter sample. Okay. What is the molarity? Okay. Mm, okay, there we go. So at this case, I need to start with the milliliters, right?
Yeah,
Multiply.
yeah, yeah. Which milliliters though? We've got 2 milliliters here, Anna.
Okay, I will start it with the. Espera un second. I will start it with the A milliliters because
Right.
I want to go to the B,
That's right.
right?
That's right.
Okay.
Eventually, but initially you want moles of A. But one sort of thing I can give you here, you see here this 4.50 molar. That's this here.
Yeah.
So we know that these two are associated with each other. We're going to multiply those together to get the moles eventually.
Okay.
Now, but
So
go on.
so in this case, I need to multiply for the 1 liters the A over 1,000 milliliter of A. Oh no.
Yes, yes,
Okay.
yes, we do need to do that. Now, the reason is because what we're looking for ultimately is this, moles of A.
Uh-huh.
We need that.
Okay.
And the only way you can get that is by doing a conversion of those milliliters into liters. Because
Okay.
what that will do is allow us to cancel everything out and just be
Mm-hmm.
left with moles of A, which is what we want at the present time.
Okay. So now I need to switch.
Mm-hmm.
Okay. So over there I need to put, let me see, A half.
Sorry.
It's okay. Okay. It's okay. So A have here 2. So 2 and
Mm-hmm.
the another one have 1.
Mm-hmm.
So 1, yeah.
All right, so the idea here is that we have moles of A, now we're looking for moles of B. That's why moles of B goes on top. Moles of A goes on the bottom to cancel. And we have 1 mole of B to 2 moles of A, so you're correct about that.
Okay, so now we need to multiply by, again, the milliliters of the B. So will be 1 over 65.00 milliliters.
That's right.
Okay, and after that, I need to cancel. Okay, 1,000 1,000 over 1 liters would
That's
be?
right, 1,000 milliliters over 1 liter.
Okay.
And that'll give us, if we cancel everything out, we'll be left with moles per liter.
More
Moles
for
of,
liters?
yeah. So
Okay.
then, which is what we want. We want a molarity of B.
Okay, there we go. So now, okay. 0 times 1 divide, okay, times 1 divide 2. Okay, so at this case, I have 3 significant figures. So at this case, I have a 3.63
Yep, that's right.
milliliter.
And it's
Yeah.
big M or molarity of B or moles per
Or
liter of B.
milliliters.
Moles per liter. Yeah.
Okay.
Either way.
Okay, not bad. It's too much information for you typing, but
No, no,
it's
no,
not bad.
no, it's all right. It
Yeah.
just takes practice is all. And I think that the main thing I would suggest is writing it down on a sheet of paper as you're doing it. No.
Okay, I have a question. Do
Mm.
you need to put the letters, for example, in the beginning it started with A, after that you have the milliliters of the A, or
Yeah,
no?
yeah,
Yeah, because I think
yeah.
the system will be
I,
wrong if you don't
yeah,
split.
yeah, that's right. Yeah, and that's just, and again, that's what I was suggesting earlier. Oops, sorry about that.
It's okay. Okay.
So the the way that you'll know what's expected is to, again, just submit an empty test and look at what's required for the
The answers.
answers. But again, if you didn't put the A's next to the volumes, that's something that we can work with.
Fixing. Okay.
I
Okay,
can
cool.
fix it later if it's an issue.
Okay,
But
yeah,
it's not
thank
really,
you.
it's not really necessary. The only reason I guess I put that in is just to make sure that people do use the right things at the right times.
Okay. Okay.
That's all.
Yeah, sure.
All right. So I mean that's pretty much it for the test. So as long as you can do those combinations that we talked about, finding molarity, finding volume, finding moles or grams, and then doing these other ones that involve the stoichiometry, then you're good. I mean, that's all there really is to it on the test.
Yes, I think it's pretty mechanic. Just
Yeah,
you need to know a little information about liter milliliters, but this is, just the numbers and what do you need to put in the right order, I think.
yeah. I think what's also really important here, Anna, is this this formula,
Yeah.
because it underpins everything and tells you exactly where you need to go and what you need to do. If you know that, then everything else will sort of sort itself out from there, I think.
Yeah.
All right. Any other questions about Module 10 here?
No, I don't really understood it, but I think I'm clear with the 10. I have a two question, but it's not about this chapter.
Okay. Well, we'll talk about that in a second.
Yes, okay.
George, you joined us.
Hello.
Hey, do you have any questions about Module 10?
Um, Not well, first off, can you hear me?
Yes.
Okay. Um, no, not really. I'm just looking through it right now.
Okay. I know you came in a little bit late, but you'll be able
Yes.
to. I will put this up, but I will get you to take a look at the recording when it goes up on YouTube, and then you can see exactly what I did at the beginning of all of this.
Awesome. Thank you.
All right. Okay. Well, if there's no other questions about Module 10, then I'm going to stop the share. I'm going to stop the recording here. And Anna, I will answer any of your questions. And if
Yeah,
anybody
sure.
has any other questions that they want to ask about that aren't related to Module 10, we can handle those off the recording as well. Okay, so I'm going to stop the recording here. Anybody who wants to leave at this point is more than welcome to do so. I do appreciate you all coming. We still want to do the sharing. We want to do the recording here. Stop.